Hello, so this is lecture 18, section 3, Deep Neural Networks for Natural Language Processing. And we're in section 3. So in this lecture, I will still use my nutshell modularity view to cover the related topics. So first, I will introduce what is natural language processing. This type of one-degree text data, what type of tasks make it interesting, or applications make this type of data interesting, and why they are challenging. And then I will cover the various of this machine learning statistic or driven type of linguistic formulations. And then the majority of the time we'll spend on the neural network architectures that now start to really influence the natural language processing. So this start from the word to vect, then the recurrent neural network, and then the one that is currently very dominating is the transformer type of neural network models. And then the last part, I will talk a little bit about this many very important self-supervised loss functions that make the above that three kinds just mentioned architecture to be very powerful for natural language processing applications. So the notable one are the skip-gram type of loss formulation and the mask, and there's something like more recent. It's called T5. So let's get started. So first, so what is the one degree type of application? What are this type of data? Okay, so now let's get started for the first module. So in module 1, let's first talk about what is natural language processing. So natural language processing is a field of computer science and artificial intelligence that to use computer it's about interaction between computers and human natural languages. So it really goes beyond the keyword match. It tries to this field, the type of task, trying to identify the structures and the meanings of words, sentences, text, and conversations. It's trying to provide deeper understanding of broader languages. It's also not just about English, it's about all the human languages. And it's really all around us. There are so many applications that the NLP technology can improve our society and our life. So, for example, machine translation. So there's just no way you can understand every possible of the human language, right? So the one classic is, can we have a automated translation? So in this case, I mean, if you ever use Google Translator, it's very impressive and can translate among hundreds of different kind of languages. So this page just shows you Spanish to English. And then the dialogue. So we're using all those automated bot, right? This assistant bot. And essentially, they are just this NLP agent trying to talk to us, interact with us. And they can help us shopping. They can help us like read documentations. There are just so many potential uses of this type of dialogue systems. And then the other is it can also help e-commerce. So the most classic application is the sentiment analysis, opinion analysis. So do you like this product, or do you not like this product? Do you like this brand? And people really like to know other people's opinion, right? And then kind of influenced upon that. So I bet you must check out what's the stars of some of the maybe keyboards you try to buy. I mean, on Amazon or some Walmart, and then make a decision about what type you want to buy. So this type of automated sentiment analysis from human people's text input converted into kind of star or popularity or probability based, and it's very enormously helpful, and it's more like a summary and then can help other customers or other product producers make decisions. And then the most classic is the text classification. We want to automatically classify or categorize your emails, right? It just has been already used enormously into different kinds, like leisure-based, work-based, or kids-based, and it's very extremely important for your productivity. So there are just so many. And then a little bit more advanced use is this automated question answering. I think you may already heard about Jeopardy from Watson. That's a very big milestone of AI, and then it's just a human agent. It's actually human interact. So this computer agent trying to compete with human on this question answering contests. And the other more now very popular use is from this automated assistant agent, like Siri, like Alexa. I bet you maybe your kids or you ask, oh, what's the weather today? And then do some simple calculations, simple search. And that's also extremely useful for productivity, right? You don't need to go to computer, open, and then type the keyboard. And now you can just directly talk. And humans are bored, to communicate through talking and through speech. And so this type of agent combined with the speech and natural language processing to interact with you. All right, so the other is this language comprehension. So we want to have much deeper semantic understanding. So for example, this is just a children's book, and then there are this kind of questions people will ask. I mean, it's not just keyword search, and you have to figure out the language structures. So for example, who wrote Winnie the Pooh, right? And this is not a very easy question if you look at this description. It really needs certain level of understandings, structures of the text. And then natural language instruction, I mean, there are many different kinds. I mean, like, for example, like the one I just talked about, like Alexa, you want to instruct Alexa maybe to open or close your lights. You want to instruct like the Alexa to make your hotel reservation or add some like thing on your to-do list. So this is not just natural language processing anymore. This is a combination of semantic speech, semantic understanding, and plus this like the underlying like maybe SQL type of operation. For example, the to-do list, this computer needs to understand where and how to convert natural language into this SQL type, database type in your to-do list. So there are a lot of really interesting and then exciting applications in this field. And one more, so like in terms of this digital personal assistant, and you just really have to also understand people's pronouns or this kind of reference, right? For example, in this case, oh, you may just talk to Alexa saying, yeah, can you like open my light? Or maybe that my light maybe just refer to your bedroom lights, right? Or maybe it refers to your living room light. So this has a lot of ambiguity in terms of you. So a assistant needs to be able to understand that level of ambiguity and also the contextual reference. All right, yeah, so this is something. Yeah, I already talked about this challenge of the understanding or analyzing the natural language text data. So the really big challenge is the ambiguity. So the most is this pronoun type of reference ambiguity. People use pronouns a lot, and then normally across sentences, you just have to be able to refer that he or she or my, this type of pronouns, I mean, to the right person, right? So it's not an easy job. And the other is language improves. Language actually grows very fast. For example, this type of word like LOL, G2G, or like this kind of short acronyms. There are also something even more my kids are talking about. I don't even understand what are they, but for them, there's a lot of semantic meanings there. So the natural language processing agent or tools should be able to grow with this type of changes. And the next challenge is natural language is text data is huge. So for example, people, like if you analyze Bible data, it's about 700K. Tree bank data, it's annotated data, it's like 1 million size now. And people like start doing a lot of, let me annotate. So the majority of the current is, so mostly training, it's on the Wikipedia. It's about like 3 billion words, about I think 20 million documentations, or maybe hundreds of million documentations. So we have, but of course Google pushes it already to the billions of. So what we're aiming for is to process every documentation, word documentation, text documentation on the web. So can you train on that? It's really a different scale, and it needs different mindset too. It's not just like machine learning. It also has a lot of things about these distributed computing, right? I mean, how do you do it fast? It's a very important question in this context. Okay, so let's now move to the next. So we talk about so many applications. Now let's see what are the underlying tasks, underlying NLP, like small tasks that made those applications possible, that are components of the previous application we talked about. So a classic NLP pipelines includes like this really a stack of components. So like text segmentation, part of speech tagging, name entity recognition, extraction, concept tagging, word sense disambiguity, syntactic parsing, semantic parsing, co-reference or relationship extraction or event extraction, and then convert this into some kind of database or relational database type of storage. So this is pretty classic NLP pipeline. So let's talk about the first. First is this part of speech tagging. So you really just try to convert each word in a sentence into their part of speech tags. So if it's, for example, this is a verb. This the only thing. This is a verb. I think this is a verb from the table. Yeah, it's a little weird why this was labeled as a verb, but this table should be noun. So this type of part of speech tags, I bet you already learned a lot in your middle school or maybe elementary school. And then the next level is to composition, this relationship among the part of speech tags, right? So this is the noun phrase. Noun phrase in this sentence includes an adjective and a noun. And then a verb phrase includes a verb and a noun phrase. So you can see this noun phrase, like, yeah, it can also appear after a verb. And then the subject. So this is the whole sentence includes a noun phrase and a verb phrase. So there's certain kind of grammar there, right? So kind of regulate how we speak. In each language, there are different kind of grammar or syntactic related like structure. So this can be reflected by the parsing tree. And then like, but it's very there are different ways to have like parse trees. It's difficult and it's easy to make mistakes. So let's, for example, look at this. So this is like eat sushi with tuna, and this is eat sushi with chopstick. And this is very clear. I mean, this tuna and this this is actually together, this make a noun phrase, right? So eat is about everything after. So sushi and with tuna and together make a noun phrase. But this eat sushi with chopstick, and this is very clearly with chopstick is for the verb. So this is the verb here, and then this is a prepositional phrase, and the whole thing actually trying to compose with eat sushi all together. So it's a very different parse tree, even though they almost have the similar, they appear the similar from the word level. So which reflected part of is like part of speech tree parsing automatically is a difficult task. Then there's next level is we want to not get a tree, but we want to get these pairwise relationships using among the words in my input sentence. So for example, in this case, so a hearing is scheduled on the issue today, right? So this is a good relationship and very clearly reflected in this sentence. And this one, scheduled and today, is very closely related with this TMP relationship. And the scheduled is not with the on, even though they are very, very close. So schedule on, actually, it's not that important. And what more important is scheduled and today, and schedule is scheduled. This is like it's passive, right? So so you can actually tell. I mean, this kind of dependency parsing can convert a word into a graph, and then you can work from there. Or maybe this pairwise, pairwise relationships, and then it give also rich representation of the sentence. So in terms of semantic parsing, you want to know the object-subject relationship between the object-subject, and even more, you can also match this to different concept. People has a knowledge basis of concept, and then how the relationship among the concept, what other relationship in my current sentence. So this is a much deeper understanding of your of the text content. Next one is called information extraction. So related to this natural language instruction type of applications, you want to connect this a lot of those unstructured text into a structured form. And the structured form are related to the SQL operations you do. So for example, in this case, there are person, company, state, and post, like positions. I mean, you want to understand them. So how do you detect? So you need to detect human names, a person's name, company name, positions, specific positions, and then the status of that person's in this company. So there are name entity recognition here, and then there's also a different level called coreference resolution task. So when talk about the same person in the unstructured text, and the writers normally don't just use the same name, right? So in this case, for example, Chris and Miss Robin, essentially they are the same person, but just that's just writing. Yeah, you don't want to repeat. Then it make it more better reading. And then they're using different kind of mentions of the same person. But as a computer, you have to normalize them into the same SQL element, right? That item in your database. And then you need to solve this task. This is called co-reference resolution task. All right, so very like a lot multiple important subtasks for this bigger for more application for NLP popular NLP applications. And then machine translation is a very important application, but it's also a very important module, NLP module, in this class NLP pipelines. So that's why I talk about translation in the application and also talk about it in this kind of task module, this module. So there are many different ways to do machine translation. So far, more dominating, like people just using like this called statistical machine translation, and using something called a parallel corpus. So you have a parallel corpus, like maybe in this case, Chinese versus English, there the translation, and or like English and Germany, English and French, and all those pair. So you have very, very good pairwise like corpus, and they are the translating of each other. So you use it to get a translation model. So this is called a translational module. And at the same time, there's a very important module in natural language NLP processing. It's called a language model. So the point of the language model is the natural language are not random permutations of words. And there are very strong dependencies among the word and its neighborhood word. So essentially, language model trying to capture that type of dependencies. There are many different kinds of language models. So like just roughly the more like relaxed way to talk about it is just the way we model a word and its neighborhood words, and then we try to predict the next word based on my the previous word, and that's the language model formulation. So to have a good statistical machine translation, normally you need two modules. So not just the parallel corpus, I mean between maybe the language you want to predict upon and predict from. You also need good language models, especially in this targeted language, and to make it sound like, so it's not just a good translation, it's also a good target language text language itself. So that's about statistics translation. All right, so we finished the module 1.